This is a smart outlet, and this is a big brain outlet, because I don't make smart decisions, I make big brain decisions. When PCBWay originally reached out, I didn't even know which app to download. It's actually pretty easy though, and I'm going to show you how to do everything from idea to finished product. This $200 battery sat discharged for months. The voltage is so low that the charger stops charging after several seconds to protect me from myself, a feature I could use in several areas of my life. But according to unverified sources on the internet, your #1 news source, I can apparently microcharge my battery enough to raise the voltage 20 seconds at a time, and then eventually the voltage will be high enough it charges normally. Now, I don't have 3 hours to manually turn a charger on and off, but somehow I found several afternoons to teach myself circuit design, so... Just like Thingiverse, PCBWay has a community tab where you can place production orders on designs that other people have made. And for the same price as a pizza delivery from across the street, my boards have component sourcing, assembly, and 2-day express shipping halfway around the planet. Again, for the price of a pizza delivery from down the street. Pretty impressive. And now, it's tutorial time. The PCB design software we're using is Kicad, which is free. And our project is quite simple, a relay with a bunch of screw terminals to all the connections. We've outlined our design goals and have a basic idea or diagram of what we need. The first digital step is a schematic in Kicad. So we'll click New, set up our directory and file name. I recommend a different folder for every project. And we enter the Schematic Editor. The schematic tells Kicad what components need to connect to what on which pins. Location here for components really doesn't matter that much, because we're going to rearrange it later when we're designing the actual board. Any arrangement here just matters for keeping things organized to where you can see it easily. We are going to need to download some footprints from off the internet though, and thankfully, Mouser Electronics makes this really easy. Footprints are the digital representations of the components we're attaching to the board. In order to make the holes on the board line up, we need to know where those pins are and how big they are. So if I go to Mouser's website, I search through the relays, find one I like. Specifically, I'm looking for one that has a footprint and a 3D file. The 3D file really doesn't matter too much for circuit design, unless you're trying to also design a casing for your project before you actually get it made. So I've got this 3D representation of the relay. I've got the symbol, which is what I'm going to use in the schematic. And then once we design the circuit board, we have the footprint here, which is the physical layout of where all those pins are. So we'll download those ECAD models and then use the library loader to convert that to a Kicad friendly format in a folder that Kicad uses in its library. So let's go ahead and start placing components. Here on the right, we've got our select and move tool, and then here we have add a symbol. It's going to load up the library, shouldn't take too long. And if I scroll on down here, I get to the things that the library loader has added. Here it is. It's in SAMIC sys parts, and then it's got the model names of each of these components. And it does have a little description, which helps. So Panasonic relay. I'm going to click OK. That's going to be our relay. To attach our wires to the board, we're going to use some screw terminals. Here I've got this one. I'm going to insert one for our Raspberry Pi. And I'm going to switch to the select tool. Click it. Control C, Control V. So we have our signal in, our power in, and our power out. And I'm going to not undo, but rotate some of these guys so that the wires are facing in. And again, you could have these oriented any way you please. It doesn't matter for the physical layout yet. Now, if I switch over to this black line, add a wire, this guy is just going to come on over. Something like that. Could have gone around. Doesn't really matter yet. Number 2, this is going to be our ground wire. And then our live AC is going to go through the relay. Goes through the common, and then this one goes through the normally open. And this is not what we wanted. Those circles mean that those wires are all connected. So we need to come up and over and connect. It doesn't matter that these wires are crossing, they're not actually going to be connected to each other. This is just a diagram. And then we're going to use these outside pins on the relay. And that's all we need for the schematic. So you would think. We also need to add some mounting holes. So if I scroll down, I can probably find a mounting hole category. Under mechanical, a mounting hole without connection, meaning it's not electrically connected like a ground or something. I want 4 mounting holes, so I'm just going to copy paste it. Before we start editing the PCB, now that we have all of our pieces, I'm going to double click on our symbols and make sure that they have a footprint. The footprint is going to be what has that pin spacing that makes everything physically fit on the circuit board. See here, it's blank for footprint, so I'm going to click on there. Scroll down the list and look at mounting holes. And now we actually choose how big that mounting hole is. Let's say 2.5 millimeters, or even better, 3.5 millimeters. Double click, and now our mounting holes are 3.5 millimeters. Once I go through and add a footprint to each and every one of these. There is a way to do it in bulk. I don't remember it off the top of my head, but I'm also linking a couple other tutorials, which you should definitely check out because they helped me, and at least one of them does cover this as well. Alright, everything should have a footprint at this point. Click on this PCB looking thing to open up the PCB Editor. And now we have this Update PCB with changes made to Schematic. It's going to want you to annotate everything. Just click that button. And here it's got a list of all the changes. Go ahead and click Update and Close. And now we have all of our components. These gray lines going from pin to pin tells us what needs to be connected. We're just going to go ahead and move these mounting holes kind of out to the sides. It can be a pain to select and move things a little bit here. And then to tell which of these 3 things is supposed to be which, I can go back to this window here. So it looks like J1 is our signal, and J2 is our in, and J3 is our out. And you can always double click where it says J1 and rename it to signal or whatever you so choose. And if I click on Update, Annotate, Update, and Close, see, it changed the name to Signal 1. And we can delete that J1 since we're not using it anymore. Alright, so we want AC in up here, AC out down here, and our signal there. Now you may notice that these mounting holes tend to be skewed to one side instead of the other. Which side is the front and which is the back? Time to look at those data sheets. Each of your components is going to have a data sheet, hopefully. It'll be right above where those links are for the files. And if we scroll down, there's something very important to note here that I missed the first time. If we see here where it says bottom view in all caps, I missed that. So what ended up happening is this relay was going to have to be mounted on the back of the board, but because there weren't solder pads there, it wasn't going to work, so I had to have the circuit boards redesigned. Thankfully, PCBWay actually caught that design mistake I made and sent me pictures showing how I had goofed up on that, and it helped me to update the PCB design in such a way that it would work and get remanufactured. For those connectors, if I pull up the 3D view here, I can see that it looks like those pins are closer to the back. So I want those pins to be closer towards the inside or center of the board instead of the outside. So that one's good. This one needs to flip around. And that one's all right. Now, because these are gonna be all crossed and all messed up, I'm gonna go back to here and select each of these sections and delete them. I'm hitting the delete key on my keyboard. So connecting 1, 2, and 3 to 1, 2, and 3, I need to flip that around. Alright, with those wires redrawn, come back over to PCB Editor, hit Update from Schematic, Update, and Close. And now that is a much simpler and easier layout. Now we get to actually start drawing the copper traces on the board. To choose manually what size we use, you can hit Edit Predefined Sizes. It'll take a second to come up, and let's add a custom track width of 3 millimeters. Now that we've created our custom track width, we actually need to select it. And now when we click over here on our front copper layer, we can actually put in some pretty thick lines. If we stick to the standard ones, they're pretty wimpy and skinny, which would be fine for this signal, but for the AC power that we're routing, I don't want all of that heat to build up and concentrate. So I'm going to use some thicker traces. With all of the traces drawn, I'm going to switch back over to my selection tool, place the mounting holes where I want them. Now we need to actually define how big our circuit board is going to be. So as we go to edge cuts, I'm going to select our line tool here. And it has a ruler to actually give us measurements as we go. We have now defined the outline of our circuit board. And if you want to figure out the distance between your mounting holes, you can use the ruler tool to get all that figured out. Super useful stuff. Now let's say that these guys had to cross over each other. Or if you just want double the copper on your board, you can add a back copper layer and it will be in blue. And let's say you need to hop lines over each other multiple times. We can come over here, and if we need to hop over here, you can see how it wants to route around it. It won't go through it. We can right click as we're placing, place through via, and now it switches over to the top layer. We come over, right click, place through via, right there. Now we're back to the back layer. So you can hop over traces multiple times that way. Hopefully your first project isn't so complicated that you need to do that, but if you need to, you can. To make things easier and cheaper though, I'm just going to use all my copper on one layer. This schematic is good to go, except for the thing I talked about before where these two holes were on the wrong side. What I need to do is right click and open in Footprint Editor. Takes a second to come up. So these two holes here, I'm holding the Shift key, right click, I can copy and paste, but because the grid system in Kicad isn't lining up with the grid system here, oh actually, it did. But now it's not lining up with this side. I need to lower it ever so slightly. Okay. This is actually my first time using the Footprint Editor that way. What I had done previously was actually mirror the whole thing and then rotate it and delete half of it. But it looks like if you move it over the old one and then move up, it will actually line it up for you. That is actually really useful. Alright, so saving this is just going to update the board we're working on and not change the footprint permanently. You can launch the Footprint Editor standalone and do it that way to update it for all future projects. So we can close out of here. And now we see we have those extra holes. So delete those copper traces. And link them up. Like so. We're going to have a duplicate set of holes here that doesn't connect to anything, but at least it will connect whichever side it has to be mounted. Let's go ahead and see what this looks like in 3D. If we hop over to View, 3D Viewer, it actually renders our board here, and we can see those 3D files put on there, our mounting holes, and we can see our copper traces. And we have that duplicate set of mounting holes. Notice how it has these H1, H2, H3, H4s. Those are the labels for the mounting holes. Hop over to that select tool and look at our front silk screen. So if I move that somewhere else, it will update here on the 3D viewer. And if I don't want those labeled, I can just double click on mounting hole, or on the text rather, and I can just make it invisible so it doesn't show the lettering at all. Likewise with these screw terminals, if I move the text out from under it, now I can actually see what's going to connect where. And I can add more text with the text tool. For instance, if I want to label things positive, negative, 12 volt, useful things like that. Little labels like that can save you a lot of grief in the long run. And then for this next trick, you don't need an NVIDIA RTX card. It will render on your CPU. You can hit there, render current view using ray tracing. And now you've got shadows, and it looks a little bit more realistic once you let it sit and render. And it is beautiful. Before we're ready to submit this for production, we need to do Inspect Design Rules Checker. And run. We have 2 warnings. Solder mask. Yep, I forgot to cover that. So what's going to happen is on this board, it's going to be the fiberglass backing and then the copper, and there's nothing over that copper to protect you from touching it, dropping something on it, or dust or something getting on it and shorting stuff out. So we need to put a protective layer over those copper traces. To create a solder mask, we're going to switch to our solder mask layer, switch to the rectangle tool, just click once, click twice, just to make a basic rectangle. And I'm going to have it cover the entire board, like so. At this point, we are ready to export the files for production. We're going to go to File, Fabrication Outputs, Gerbers. We're going to make a custom directory, make a new one, call it Gerbers. Select that folder. If you want to make that path relative, I suggest hitting yes here. You can pretty much just leave all of those settings default and hit plot. I don't know if they ended up using my drill files or not, but it takes me just a couple clicks to generate them, so why not? Instead of uploading those files directly, we go over to the Gerbers folder, select everything there, right click, send to zipped folder. Give it a name, and now we can go over to the PCB website to get it manufactured. One other thing I should have mentioned earlier perhaps is all of the components I've been using are through hole, meaning there's a pin that goes all the way through the circuit board. If you're trying to use surface mount, you're going to need a pick and place file. As long as you're sticking to through hole, you're not going to need that. But once you get into surface mount stuff, it gets a lot more technical, and I can't help you at that point. Our board is one layer. We want 5 of these. We have copper on the top, a solder mask on the top, and a silkscreen on the top. We get the size of our board from the ruler tool, but just to throw in some random numbers here, it's all one design, single pieces. We can choose the material. We could get this made on aluminum if we so desired. We can choose the thickness of the board material. We can choose the color of the solder mask. This is essentially the color of the board that you're used to seeing. And you can choose the surface finish. And we'll go ahead and hit calculate. Now that we've got an idea of what it's going to cost, we can choose our production speed and save to cart. Now we're going to add our Gerber files and click submit order now. Now this doesn't mean you're necessarily obligated to pay at this point. They're going to audit, review it, make sure it's producible and you're not missing any layers, sort of basic mistakes like that. And if you want to include assembly, like I did, you would have this done, and then you would go over to get assembly quote, board type with single pieces, we're assembling on the top side, the total quantity of single PCBs, we're making 5 boards, the number of unique parts, we have 2 varieties, the relay and the connectors. We have 0 surface mounts, 0 ball grid array, and here we have the total number of through parts per board. So in total it's going to be 20 parts, but for each board it's only 4. And yes, we have an order number. It is this one, tutorial.zip. So now they know what to assemble it on, and you can throw in any extra comments here, and we'll get our calculation here. And of course, how are we going to acquire these parts? You can have PCBWay acquire them, you can mail it to them and then have them mail the assembled boards back, or you can do some combination of the two. I had PCBWay acquire mine. There is a bill of materials template file that I highly recommend taking a look at. So just replace the text here with whatever it is you've got. So the quantity per board. Everything is going to be through hole for what we designed. This is the manufacturer's part number, the manufacturer name, and then here the designator. That is going to be, if we hop back over into Kicad. So K1 is our relay, and then signal 1, J2, J3, those are going to be those terminal blocks. So you'd put J1, J2, J3, and K1 for your designators. And then you could put your order number up here and then hit save and you're good to submit it back. Alright, so my boards have been produced, they've shipped halfway across the planet, and they are here. Has my big brain move paid off? Well, in order to make it work, I used a Raspberry Pi 2 because the Raspberry Pi 3s and 4s are horribly overpriced right now. I opened up Scratch, created a simple program to turn the power on for 20 seconds and off for 10 seconds, and this was enough to trick the battery into charging 20 seconds at a time. I also have the cat character telling me how long we've been at this, keeping track of how many power cycles and minutes we've been running, and he also tells me if the relay is on or off by reminding us to like and subscribe. And after a few cycles it'll try and charge normally so I can keep track of if I'm done microcharging. And well, it worked. This $20 per board solution saved me a $150 to $200 battery. A pretty good deal. Plus I have 4 extras that I can use for other projects around the house. PCBWay also offers CNC machining, sheet metal fabrication, 3D printing, and injection molding. I haven't finished this design yet, but I do have a project in the works where it's a 3-rack unit server, except that it houses a bunch of Raspberry Pis that slot in with 3D printed caddies, and you can also fit 3.5-inch hard drives, so you can either have a bunch of hard drives mounted in there to one Raspberry Pi, or a bunch of Raspberry Pis and a little bit of storage. It's all powered by a single ATX power supply, so you've got your 24-pin going into this circuit board, and then you have some GPIO for one Raspberry Pi to control individual power to each of the USB and Molex ports. I've linked a playlist and some other videos down below that I highly recommend you watch to get started with Kicad. If seeing me learn stuff the hard way is fun, check out the 3D printed kitchen countertop video, and in the meantime, I'm going dad mode and setting these 4 extra smart outlets up with speakers to say, hey, you left the lamp on too long, you can leave the lights on when you pay the electric bill, and turn the lights off automatically. See you in the next one.